Okay, so after we discussed the how to form the vector equation for the straight lines already, so now we proceed to the next part. So this coming part we are going to talk about a pair of lines. So in the previous part we are talking about how to form the vector equation for one line, right? So now we are going to discuss about a pair of lines, and then the learning outcome for this part is actually you need to know how to you need to determine whether the two lines are parallel, intersect, or skewed. All right, so there are three important words here that you have to understand and you have to know how to decide, okay, or how to determine. And after that, if let's say you know that they are intersecting with each other, then you need to know how to find the coordinate of the point of intersection, okay, when they intersect. All right, so mainly we are going to discuss all this only in this part. Okay, so just a very simple concept for you all. Parallel, I think all of you should know. So parallel means that they are in the same direction. They are parallel to each other. All right, so intersect means that they touch each other for the vectors. Okay, and after that skewed. So for skewed case, it is a bit more complicated. So it will appear only on 3D. Skewed, you can have a look here. The red color and the blue color line we call as skewed lines. So that means they skewed means that they not intersecting each other, not intersect with each other, and then they are not parallel to each other as well. So we call them as skewed lines. Okay. All right. So skewed case only appear in 3D. 3D means that three-dimensional case like when you're having the vector with ijk or maybe xyz, then only you will have the skewed case. All right. So skewed case will not appear in 2D. Then parallel intersect will appear in both 2D and 3D. So the skewed case is something special. It only appear in three-dimensional cases only. Right. Okay. So this is what are we going to do for this part. Okay. So we need to know how to determine. All right. So to determine all this, right? Actually, there's a process for you to go through. If let's say you want to know the exact process. So here I actually draw a summary. If you have time, you can pause the video here and then you try to copy this summary in parts of any part of your notes which is easier for you to refer. Okay, so when you're having a pair of lines, right? So assume that I'm having line number 1, R1, and also line number 2, R2. Okay, so they are in vector equation form. Okay, A plus TP and also B plus SQ. All right, so every time when you want to double check and see whether which case they belongs to, there are a few criteria that you need to check. So the first one is you double check with the P and also the Q, the direction of the line. Okay, so you can see that this is P and this is Q, right? Okay, so first of all, you check and see whether P is a multiple of Q or not. So you have yes and no. Okay, so if yes, then usually you know when the direction, the line of the direction of the line, they are multiple of each other, so it is generally parallel. But in the previous video we learned also, right, for vector equation they are not unique. That means the equation might look different, okay, but actually they are belongs to the same line. So the first question you just need to double check and see whether P is the multiple of Q or not. If yes, then you have to double check another thing, another criteria here. Is A minus B a multiple of P, or is A minus B a multiple of Q? You can also use B minus A. That means you use the passing point of both lines minus each other, and then you see whether is it a multiple of the direction of the line or not. If after you minus, you realize that it is also a multiple of the direction of the line. If yes, then actually R1 and R2, although the equation looks different, but they are actually referring to the same line. So you have one case here, which is the same line. So if you take A minus B and it is not a multiple of P, so that means R1 and R2 are parallel. Okay, so these are the criteria that we go through. All right, so first of all, you check whether the direction of the line P is a multiple of Q or not. Then you check the second criteria is you take the passing point minus the other passing point and check whether is it the multiple of P. Okay, so if yes, then same line, no, then parallel. Okay, so all these criteria can appear in both 2 and 3 dimensional. Okay, so we go back to the no answer just now. So if let's say P is not a multiple of Q, Okay, then the next thing that you need to double check is you let R1 equals to R2 and you find the value of S and T. Okay, so when you try to find the value of S and T in the 2D cases, right, very easily, you can actually make a conclusion that you have intersection point. R1 and R2 intersect. But if you are having 3D for that particular cases, right, for that particular question, for 3D cases, then you need to further investigate and see whether S and T is consistent for all the component IJK or not. If yes, then only they intersect. If no, then they skew. The R1 and R2 are skewed. So this is generally a summary for you to double check and to go through when you want to determine what is the relationship between the pair of lines. Okay, all right. So for your information, when you have or when you decide the intersection point already, when you already know that R1 and R2 are intersect with each other, to find intersection point, you just substitute the S or T. Sub the value S or T that you get just now into the vector equation. Then the answer that you get is already the intersection point. Either one. Okay, substitute the value for S or T. Okay, and then for intersection, you also can find out the angle. Okay, so to find the angle between R1 and R2, the concept is almost the same like what we learned before. You use the formula P dot Q equals to modulus P modulus Q and then cos theta. Okay, so these are the important things that you need to know. So there are two important things here. First, you need to know also how to find the intersection point when two lines are intersect. And after that, you also need to know how to find the angle between the two vectors. So when the vectors are intersecting, then you can find the angle between them. For skewed case, you also can find out the angle between the vector equation. Alright, so you can see that for the formula here, we are using the direction of the line to find out the angle between the two vectors. Okay, so if you scroll further in our notes so you'll see that there are some explanation here. All right, so generally all these explanations are summarized in the diagram that I show you just now. Okay, so I'm not going to go through with all this stuff in detail. So if let's say you're interested, you can just have a look at. All right, in my opinion, right, I do think that the diagram, okay, is easier to understand instead of the explanation here. Okay, so you can go through with it if you are interested, and then just make sure that you know okay, how to find the intersection point and also the angle and how to determine what is the relationship between them. Okay, so let's continue. Okay, so maybe here you can highlight this one. Okay, so to find the intersection point, you let R1 equals to R2, you get the value of T and S, and then you substitute the value as what I mentioned to you just now. Okay, then if you want to find the angle between the two vectors, so the vector equation is you need to use the direction of the line only, not the whole equation, but it is only the direction of the line. Okay, so just highlight this because it is quite important. Okay, so now let us discuss some example here. Okay, so if we have a look for example 15, so if you look at the question they are asking find out whether the following pair of lines are parallel, are they non-parallel, intersect, or skewed. Okay, so if the line intersect, they want you to find the intersection point and also the acute angle. If let's say the line is skewed, then you need to find the acute angle between the lines. Okay, so first of all, we have part A. Okay, so part A, very obvious, you see that this is a 2D dimensional case, two-dimensional case, right? So you can assume that this is A plus SP, up to you it is A plus SP or A plus TP or whatsoever. So you just need to make sure that you know the 1, 1 and also the 1, 4 will be your direction of the line. Then 1, 2 and also 3, -2, these two are the passing point of the line. Okay, so we will start doing and investigate what's the relationship between this pair of line. Okay, so first, if you refer to the diagram here, they ask you to do what? Okay, sorry, maybe I can copy it down. Okay. Okay, so first of all, they ask you to check whether P is a multiple of Q or not. Okay, so once you see this, then you decide, okay, your P is 1, 1. Q is 1, 4. Is P a multiple of Q? So you can write out 1, 1 is not a multiple of Q. Okay, it's not a multiple of 1, 4. Therefore, you go to this part, no. So the second step is you need to go through with the second checking criteria. You need to let R1 equals to R2 and find the value of S and T. So since you know that they are not parallel to each other, right? And this is 2D cases. So what is the conclusion? So R1 and R2 are intersect with each other. Okay, so you can find out the intersection point already. Okay, for 2D cases. Understand what I say or not? So this is how we use this diagram. Okay, right. So now I will erase it to have more space. Okay, so that means I need to let R1 equals to R2. All right, so I'll put it in this form now. 1 plus S, then 2 plus S is equals to 3 plus T, and also -2 plus 4T. Okay, so how to solve and how to get the S and T? So again, as what I mentioned before, you compare X component with X component, Y with Y. So that means you have first equation here. This is the first equation, and this is the second equation. Okay, so this is the first equation, and this is the second equation. So you try to solve the simultaneous equation to get the S and also the T. Okay, so maybe the first one, S is equals to 3 plus T, right? 2 plus T, sorry. So you can write, maybe if I want to write it out in a clearer way, then I try to do it in this. Okay, so from here you can see that you are having 1 plus S, which is equal to 3 plus T, and therefore S is equals to 2 plus T. This is your first equation. Then for this part, you are having 2 plus S equals to -2 plus 4T. So if you continue further, you have S equals to -4 plus 4T. So this is your second equation. So no matter how, you just try to solve the simultaneous equation. Okay, so if you solve simultaneous equation from here, okay, so for me, I will get T equals to 2. Alright, so I'm having T equals to 2. If you want to find the value of S also can, but for this case, I'm not going to continue to find the S because the value of T is enough for me to get the intersection point. Okay, even if you find out the value of S, you substitute S into this vector equation, both answer will be the same. So it is okay if let's say you don't really go and find out the value of S. Okay, so I will get T equals to 2. Alright, so substitute T equals to 2 into your equation, your vector equation R2. So R2 is equals to 3 plus 1T, right? So 1T, T is 2, and then -2 plus 4T. 4T means 4 times 2. So your R2 is equals to 3 plus 2 is a 5, and then for this one is 8 minus 2, you get a 6. So this is actually your position vector for the intersection point between these two lines. Okay, so before that I told you, right, in the very first or the second video, when we talk about the vector equation, generally when I substitute some value into the t, it is the point on the line. So this particular point is the intersection point on the line between R1 and R2. So I need to make a simple conclusion here. So you can say that R1 and R2 intersect with each other. Okay, and 5, 6 is the intersection point. So is the intersection point. So you realize that I write 5, 6 in the Cartesian coordinate form. Alright, because they're asking for the coordinate for intersection point, and therefore this is what I do. Okay, I will write in the Cartesian form. Okay, so I already make a conclusion about the intersect between R1 and R2, and I get the intersection point already. Besides, they also want us to continue to get the angle between two lines, right? Okay, so how to get the angle between two lines? Okay, so to get angle between two lines, what you need to do is you apply the formula. So I think I told you before, right? When you want to apply the formula, you have to use only the direction of the line, 1, 1 and 1, 4. Okay, so I'm using some other color to continue, okay, with the direction of the line. Sorry, angle of the line. Okay, so let me start. You want to use P dot Q. So P dot Q means 11.14, which is equals to modulus P. Modulus P means 1 square plus 1 square, multiply with modulus Q, which is 1 square plus 4 square, and then cos theta. Okay, so 1 times 1 you get a 1, 1 times 4 you get a 4, okay, divided by square root 2 and also square root 17, and it is equals to cos theta. Alright, so if you continue from here, eventually your theta should be equals to 31.0 degree. So they are asking for the acute angle. So if you get any negative value here, you just ignore it and then change it become positive to get the acute angle. Alright, so 31 will be the angle between the two lines. Alright, so this is generally how we determine, okay, whether the pair of lines are parallel, intersect, or skew. So this is the first case where we are having the intersection pair of lines. Okay, the pair of lines are intersect with each other. Okay, so if no problem, then I continue further to the second part, part B. Okay, so maybe I need to erase this for now. Okay, so let me have a look for part B. Okay, so again, part B, if you look at the question, it is also the two-dimensional case. All right. So first, I want to check whether P is a multiple of Q or not. So I will let P equals to 4 and negative 2. Then I can simplify it further, which is 2 and negative 1. For Q, I get negative 6 and 3. Then I realize also I can take out negative 3. So if I take out the negative 3, I will get 2 and also negative 1. So if you double check the basic vector of the both direction, they are actually the same. Therefore, when you want to make you can make a simple summary first. So P is a multiple of Q. Okay, so that's the first criteria that you need to double check. Okay, so you go to the next, you go to the yes part in the diagram that I show you. Okay, so what's the second criteria that you need to check now? So you have to take A minus B. All right, so when you take A minus B, you can have 3, 1 minus 1, 2. Okay, so when you're having 3, 1 minus 1, 2, you realize that it is 2 and negative 1. So double check again. The A minus B, is it a multiple of P or not? So you will see that the basic angle, sorry, the basic vector for the A minus B is also the same as the basic angle, basic vector for the direction. Okay, so which means here you make a summary. A minus B is also a multiple of P or a multiple of Q. Alright, so after you go with the table, what will happen? So you will see that you will come to a conclusion, right? So what's the conclusion here? So you can see that R1 and R2 are the same line, referring to the same line. Because although the equation looks different, the vector equations look different, but actually they are the same line because of you are using different passing point. Alright, so you will see that the vector equation is not unique. Okay, so I hope that by referring to the diagram at first, you roughly have the idea what are the criteria that you need to go through and check first. Alright, okay. So for this video, I will stop here for two-dimensional cases, and then in the next video, we'll discuss further for the three-dimensional cases one.